Jai Jayendra, Namaste. My name is Sayam Jain. Welcome to my channel. Today we are going to solve the 33rd question of the problem solving series, which is based on binary search. So this is the third question of the binary search. In the previous question, in the previous video we solved the question of searching the element in rotated sorted array. But in these questions we need to find the minimum element in the rotated sorted array. So the difficulty level for this question is medium, and this question has been asked in multiple big MNCs like Amazon, Microsoft, Google. It's a very popular question. So finding minimum element in rotated sorted array. We know we can use binary search in sorted arrays only, and this array is sorted but it is rotated, right? For example, here 3, 4, 5, 1, 2. So when 1, 2, 3, 4, 5 is rotated twice in anti-clockwise directions, then it becomes 3, 4, 5, 1, 2. That means 1 and 2 comes to the leftmost part of it, right? And goes to the back part of 3, 4, 5. So here in this array, if it was 1, 2, 3, 4, 5, we would have directly known that since it is a sorted array, the lowest would be the first element, right? But this has been rotated. Now here 3 is not the smallest element here. Okay, so by normal linear search we can easily find the minimum element, right, in order of n. But obviously we need to optimize it. We need to use binary search. We need to solve it in order of log n. So the answer is 1, we know, and here the answer is 0, right? But how do we solve this problem using binary search? So in the previous question we know how do we search the element in sorted array, right? So same logic we will be using it, but we need to find the minimum element. So how we will find the minimum element? Suppose if we use binary search over here, the low being this index 0 and high being 5th index. So our mid would be 2nd index, right? So now, so it is actually 0, 1, 2, 3, 4. Okay. So now mid is 5 and our low is 3. So what do we know from this? What can we figure out? That low is actually lesser than the mid. Low's value is lesser than the mid. What does this means? That this part must be sorted. That's why it is possible, right? In the previous video we have seen that condition. How do we search? So we know this part is sorted, and since this part is the sorted, so one possibility could be that this is the smallest element if it is not rotated, right? So this could be the smallest element. Even we can save it in another variable that this could be a smallest element. What is the other possibility? That if in this left half this is the shortest element, so this part won't be the sorted. So let's go to the next half. So we'll eliminate this half and we'll go to this half. We'll make since this is low is less than mid, so what we will do, we'll make low as mid plus 1, right, here, and high would be the same too. So 3 and 4 would be our low and high, and then we will see the mid becomes low plus high by 2, that is 1, right? So now mid index should be 1 and low's index should be low's value will also be 1, mid value will also be 1, right? And now area of low would be lesser than equal to mid. So we'll come to know that okay, this is lesser than equal to mid. So this could be our answer because this is sorted now, right? So what we'll do, we'll again compare with the previous smallest element, and since 1 is smaller than 3, so 1 will be the answer. And then if we do again low plus high by 2, then low and high will be equal to, right? When we'll change this, so we will come out of the loop the normal way which we do in binary search, and we'll get our answer as 1. In this one also, what will happen? 0, 1, 2, 3, 4, 5, 6. Also, if the array is sorted already, it could be that it is not rotated. So we can skip it in the beginning also, or we may not skip it. We can have a condition that if array of low is less than equal to array of high, then also we'll store the result. When I'll code it, then you will understand it. I'll try run my code in this example, right? So what we have done over here? So we have int low is equal to 0, high equal to array dot size minus 1, and obviously I'm coding in C++. But the logic would be same. And now our mid would be low plus high by 2. Right. Now we will have our condition that while low is less than high, and we'll have our int as answer, and answer we will store as the maximum element, right? Okay, anyway we will get the one of the element would be obviously the smallest, so we will have int answer as the int max. And now what we will get, we could have written this line over here, but no issue. Mid is equal to low plus high by 2, right? Every time we calculate this, every time this value will keep on changing. And if array of low is less than equal to array of high, right? That means the array is sorted already. There is no rotation. So what we'll do, we'll store answer as array of low, right? Answer as array of low, and we will make low is equal to mid plus 1. If there is a possibility that in the other half it could be, but that we will see whether we get a better answer or not, right? Else if what we'll do, we will check the value of array of low with array of mid. So if array of low is less than array of mid, like in this case, that means this is sorted. So since this is sorted, so our answer would be, actually here also answer would be max of, answer would be max of array of low comma answer, right? And here answer would be max of mean of, we are trying to find the minimum element, mean, and here answer would be mean of answer comma array of low, since array of low is smaller than array of mid, right? And what will happen, we'll go to the eliminate the left half, the sorted part. So mid would become, low would become mid plus 1, low would be mid plus 1, right? Else what will happen, we will find answer as minimum of, if it is not sorted, right, then we will if suppose this is array of low is greater than array of mid, right, that means this part is sorted, so our answer would be minimum of answer comma array of mid, right, since this is lesser than the low. And we will make as high as, we will see in the other part which is not sorted. This part is sorted, so this will obviously be smaller than this, right? So I will be mid minus 1, we will go to the left part. The right part is sorted, so we will find the minimum between answer and array of mid. Okay, and in the end we will return our answer. Let me try run this code for this example. Okay, so 4, 5, 6, 7, 0, 1, 2. What is the mid value over here? 0 plus 6 by 2. 0 plus mid is 0 plus 6 by 2, that is 3. Okay, so A3 is the mid, right? Now this 4 and this 7, right? So what we can see that first 4 is actually this condition, low is less than high, is everything sorted or not. We can see low is greater than high, that means it has been rotated, right? So we will not go to this condition, we will go to this condition. Is array of low is less than mid or not? You can see 4 and 7. Array of low is less than array of mid, which means that this is a sorted part, right? So we will go to this condition and we will have the answer. What will be the answer? Max int max and array of low, that is 4. So our answer in the first case is, first one is 4. Okay, and then we will go to the right part, because we have got our answer in the left part. We will see in the right part do we have a smaller number or not. So low becomes mid plus 1. So our low is now 4th index and our high is 6th index, right? So what would be the mid now? Mid value would be 4 plus 6 by 2, that is 5. So this one. Now we see our low is 0, mid is 1 and high is 2, the indexes. Now we see that, okay, low is less than high, 0 is less than 2, right? So since this is true, our answer would be minimum of array of low and answer. So what is the low value here? 0. And what is the answer? 4. So answer would become minimum of 4, 0, which is 0, right? So we have our answer as 0. We have got the answer as 0. And now again, what we will do? We will go to the mid plus 1 because we know this part is shorted. So we will check, okay, this is shorted or not. So our low increased to 1 and high increased to 2. Again, we will be finding it and we will see at one point this will terminate, and already we have the minimum value, nothing can be smaller than 0. So we will get our answer 0 in order of log n, right? So I think the solution is clear. Please, the link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section. What is the time complexity? Order of log n, since we are doing binary search.
Here is the code walkthrough of this question. You can see in the LeetCode platform, find minimum in rotated sorted array. The companies, you can see the name of the companies for which this question has come. So as we have discussed already, so here is the implementation in the proper way. So we are checking here whether we get the answer here or not. If it is, like, I forgot to add this break condition, because if the low is less than high, array of low is less than high, and we get our answer here, what does this mean? This means that the array is already sorted and we are not going to get any number lesser than array of low. So here we return the answer directly over here, and here we eliminate the left part by keeping the minimum, and here we eliminate the right part, and so here we return our answer. Okay, so let's run this. It's accepted for the 3 test cases, so let's submit this. So this code has worked. Also, find minimum in rotated sorted array. This question can also come as that, find the number of rotations. Okay, so for finding the number of rotation, the code would be same, because here we are returning the minimum, the answer. Okay, but if we return the index instead of this array of low, if we return the index low, then the lowest, the minimum's index is the number of times it has been rotated, right? So if it have been rotated 3 times, then the array of the 3 would be the lowest, because it is rotated from the first, right? And the sorted array is our array, which is sorted, and if it is rotated, then the first element is always the minimum element, right? So its index will give us the number of times it has been rotated. So this question can also come as find the number of times the array has been rotated, and it will be implemented in the same way. Okay, so I hope the code walkthrough is clear, and we'll see in the next video where I'll be explaining the 34th question of the problem solving series. Jai Jinendra.